Hello, my name is Gabriel Duiti and I am from Brazil. This video is part of the final project for the course Management Machine Learning Projects offered by Duke University on Coursera. The goal of this final assignment is design and present a machine learning solution using CRISP and the EM framework and the key system design principles. My project is called Smart Turning Optimization Systems.
The problem I am addressing is the inefficiency and the complexity in selection optimal parameter for industrial turn process. Traditionally, the selection is based on static tables, expert knowledge, or trial and error. These methods are not only time consuming, but often suboptimal. This represents a great opportunity for machine learning. First, because there is a clean predictional task, estimate the optimal cut parameter such as speed, feed rate, and depth of cut. Second, because we have access to sufficient data, including historical, machine records, and simulation results. And third, because the business value is high. Optimizing this parameter can lead to significant gains in productions and reductions in material and tool waste. In the business understanding phase of the CRISP-EDM framework, the objective of this project is to recommend turning parameters that maximize the productivity without violating safety or quality constraints of the process. Success in this project will be measured using two main metrics. The first one is the material removal rate, or MRR. Higher MRR values indicate better productivity. The second one is surface ruggedness, or RA, which must remain within acceptable tolerance limits to ensure production quality. Several relevant factors influence these outcomes include the material type, the tool geometry, the machine's powers available, and the results from preview cuts. The proposed solution is a recommendation engine that predicts its optimal turn parameters using supervised machine learning models, such as regressions or decision trees. To validate this concept, I will conduct a series of experiments in three stages. First, I will start with simulation datasets to verify the model's basics are currently under controlled conditions. Next, I will collect feedback from domain experts to refine the model's constraints and ensure that the recommendations are practical and realistic. Finally, I will perform A/B tests comparing the model's recommendations with traditional methods in lab or pilot production settings. For systems design, I made three main decisions. First, I chose cloud deployment to centralize data and simplify retraining. Second, I use offline learning since the data changes slowly and periodic updates are enough. Third, predictions are made in Bath model, journalizing recommendations before each production's run. There are a few productions risks to consider. One is the concept drift, caused by changes in the material or tools. Another is data bias, which can affect generalizations to Rails cases. Latence isn't a major ensure here because predictions are made in Bath model. To address these risks, I plan a regular monitor, retraining, and human in the loop validations when when needed. In conclusion, this project brings machine learning to the shop floor in a practical and a measurable way, following a structural process to reduce the risk and maximizable the value of the production's internal process. So, thank you for watching, and I hope you enjoyed it, this presentation. See you soon.